Pythagorean identities. So this is the start of learning how to write one trig function in terms of another. We've done a bunch of trig identities already, and they're down here. So we can write, for example, write cosecant in terms of sine. Cosecant is 1 over sine. Sine is 1 over cosecant. Now you can square those, you can cube them, and it would be cosecant squared is equal to 1 over sine squared. So these are all different ways we can use these things. Okay, this stuff needs to be memorized. You need to know all those. You need to be able to write one trig function and in terms of another. And these are the reciprocal ones, we call it, and this is tangent in terms of sine and cosine. So we have another one that isn't so straightforward and obvious. It's called the Pythagorean Identities. And they all start from the Pythagorean Theorem, as you might guess, because the Pythagorean Identities. So if you remember, just getting nauseous here. If you remember this unit circle here, and we can draw this triangle where this is the x and this is the y, and the hypotenuse is 1. X and y become the legs of the right triangle, whose hypotenuse is 1. And if you use the Pythagorean theorem on this, you get this. And then magic, magic, that's my symbol for magic, using, remember, x is your cosine, and y is sine. Get anything out of the unit circle, you get that. X is cosine, y is sine, so rewriting x squared, y squared equals 1, we have this new identity. Whenever you square, if sine squared of 30 plus cosine squared of 30 will always be 1. It's a pretty amazing concept. Oh yeah, see? It's true because it's written down. Okay, so that is the Pythagorean identity. And then we use all these identities, and we can prove one thing is equal to another. So today is just the start of that. The first thing that I want to let you know is down here, if you do have to have this stuff memorized. And I have created flashcards at cram.com. If you search for Barris, spelled like this, and you look at Barris Trigonometry Basics or Barris Pythagorean Trig Identities, they will help you memorize these because you do need to know. All right. So from this one Pythagorean identity, we can create basically an infinite amount of other ones. But there's some regular ones that we transform this from sine squared plus cosine squared equals 1 to other things. So what I mean by transform is I perform some sort of math. So the first kind is I can transform it using adding and subtracting. So in other words, I can just rewrite this one, say I subtract cosine squared. From both sides, it would cancel out from this side, and now I know that sine squared theta equals 1 minus cosine squared theta. So there's a new identity. I now know sine squared theta is equal to 1 minus cosine squared. Yay! And you can do the same thing with sine. So I'm just going to, just so you have it, so you can see it right away. Okay, I could also subtract sine squared. Subtract sine squared. And I'll get cosine squared theta is equal to 1 minus sine squared. That's a sine. Okay, so those are a couple other ones. Now, you don't technically have to memorize it, but you do have to know how to get it from there. So you could know that cosine squared is 1 minus sine squared, or you could know this one, and if I can subtract, those kinds of things. The other kind that you can do is dividing. So when we divide, it allows us to use the reciprocal function. So if I divide all of this by, let's say, sine squared, if I divide everything by sine squared theta, that means, I'm just going to write it for each one so you can see. I get this. I get sine squared divided by sine squared plus cosine squared divided by sine squared equals 1 over sine squared. That in itself looks hideous, but if you look at it closer, you see sine divided by sine squared divided by sine squared, that's simply just 1. And I know cosine over sine is cotangent, and 1 over sine, or 1 over sine squared, is cosecant squared, using the ones on the front of this page. So there's a whole new one right there. Okay? And then from there, I don't know if it's going to let me erase after all that. No. Okay? So then from there, we can also, instead of dividing by sine, instead of dividing by sine here, I can also divide by cosine. So I'm just going to move over to the side and do it over there. Okay, so I'm going to start with sine squared plus cosine squared theta equals 1. So that's always where we start from. And we can add and subtract, and here I'm dividing. So this one I'm going to divide by cosine squared. So when you divide, you have to divide into all pieces. So maybe you can pause it and see if you can figure out what each one of those is. Okay, so sine squared over cosine squared. Sine over cosine, that's tangent. So I'm squaring those, so I'm squaring that. Cosine over cosine, well, that's 1. And 1 over cosine squared, that's secant squared. So there's a whole new one. So those two other trig functions, or trig identities that we can talk about, there's these two now. And now from there, I can add and subtract them. Just like we did up here, where I added and subtracted. You know, I subtracted sine from both sides. I can come down here and add and subtract from both sides. So I can take cotangent and subtract and bring it over here. Or I can take whatever. Okay, so all, as you can see, there's a whole millions of them that you can do. But if you can always start with sine squared, cosine squared, and either add or subtract or divide by the same thing, and you'll get some new kinds of trig functions or trig identities that you can use. So these are the two new ones. 1 plus cotangent squared theta equals cosecant squared theta, and tangent squared theta plus 1 equals secant squared theta. So from there you can, I don't know, so you can subtract 1. Okay, so it's hard to say how many you have and how many you can use, but I know cotangent squared is cosecant squared minus 1. So as long as you can use math to change things around, so same deal here, I can subtract 1 here, and I get tangent squared equals secant squared theta minus 1. So there's a lot of times where we're going to need to rewrite one trig equation in terms of another. Okay, prove that two things are equal, those kinds of things. And this is the start of that. Okay, so, I mean, I could do a million of these, but I'm going to stop there and go to the next page. Now, the next page is a whole nother file for me, so it's going to be a whole nother video. So this is just the beginning. These are the Pythagorean identities. Open up the next video for to actually start going through them.